In this video, we're going to look at the homework. But before you watch my video, I strongly recommend that you do it by yourself before you watch it. If, for example, if you need help at some point, you finish everything by yourself and you need help at some point, then you watch a video and then you go to that point and watch that, say, how to do that problem particularly, okay? And I don't suggest you just watch video and then do the homework because you really don't think too much and probably don't learn too much from the class. So I would or learn too much or really master the point. So I hope you can first try it by yourself. If you really have a problem, then you watch the video. Okay. So experiment involves tossing a pair of dice, one green and one red. Record the numbers and come up. If the X equals outcome of green die and Y equals outcome of the red die, describe the sample space. Basically, for each die, you have 6 outcomes. So I think I've given you an example before in the previous video before. So it's 1, 6. I should have used that. Okay. So you can do 1, 6, and 2, 6, 3, 6, 4, 6, the first one, and 5, 6, and 6, 6. The first one could be 2. Or why do I always start from 6? The 1, 1, 2, 1, 3, 1, 4, 1, 5, 1, 6, 1. Okay, 7, 2, 1. No, 1, 2. Okay, 1, 1. Oh, my bad. The first is 1. It's always 1. The second one can be 6 different things. 1, 3, 1, 4, and 1, 5, and 1, 6. The second one can be 2, 1. The first die is 2. Second die is 2. First die is 2. Second die is 3. First die is 2. Second die is 4. And you continue. That's all the probability combinations. So continue. You have 3, 6 here. And your last one is going to be 6, 1. And continue 6, 6. Totally, you're going to have 6 multiplied by 6, 36 outcomes. Okay. So, describe the sample space. The sample space will be 1 less than equal to x less than equal to 6 for x, and also for y is 1 less than equal to y less than equal to 6, and x and y must be integer. It should be right. The question doesn't say that, but x and y should be integer, not any number, not 1.1, 1.2. It has to be a natural number. Okay, so 1, 2, 5, 3, 4, 5, 6. Although it doesn't write here. Second problem, you have I have 3 rivers. So each river you can have you have 3 rivers, right? So each one you can get F and N. Safe, not safe. Safe, not safe. Okay. Safe, not safe. Safe, not safe. Yeah, do the same thing in this one too. So 1, you have not safe, and then the second one, safe, not safe, safe, not safe, and safe, not safe. So basically 1, 2, this is 1, 2, 3, 4, 5, 6, 7, 8. Okay, 6 combinations. So then you put it here, you can see all of them. The last one is N and the first one is F, F, F. Then you have that, okay? And then list the elements of else corresponding even that at least 2 rivers are safe. 2 rivers are safe. The first one is okay. The second one is okay, safe. The third one, 2 safe. You basically need 2 F. You have this 2F. You have 1, 2, 3, 4. So you have 4 cases. So you have this one. Okay, the first one. And I'm going to skip the third one. It's easy. Okay, so this one I'm going to just explain one of them. I don't think it's really hard. So let's look at say S is 0 to 9 and A is 0 even numbers, B is odd numbers, C is 2, 3, 4, 5, D is 1, 6, 7. So A union C, basically just add, put all the A and C numbers together. 0 from A and 0, 2. And of C you have a 3. Although 2 is, C has a 2 but it's right here, you only have write it once. So and 3 and 4. And C have a 5. And A has a 6. And A has 8. So that's A union C. Okay, A intersection B, which is the common numbers of A and B. Common numbers of A and B, A is all even, B is all odd number. There's nothing in common, so it's an empty set. Okay, C complement set, which is whatever is in C but not in whatever is in S but not in C. Okay, S has a 0, C does not have, so 0, and S has a 1, but C has a 2, so 2 is C. Complement set is everything not in C. Okay, 0, 1, 2, 3, 4, 5. Okay, it's in C. So 6, 7, 8, 9 is not in C. That's the complement set of C. Okay, now I'll continue. This problem, M union N, I just give you one, M union N. Since M is from 1 to 9, so it's 1 to 9. N is from 0 to 5. Okay, so if it's a union, so it's all, if it's a union, so add all of them together, then it's going to be from 0 to 9. Okay, you can do that by yourself and type it in. You probably have more, but it's same idea to complete that. Okay, I don't think that's really hard. The second one, you ask for intersection. This is for this is for union. So second one, if we do intersection M, it's going to be the green part, the common part, the green part. Okay, the common part green is going to be from 1 to 5. Not really hard, right? Number 5. Okay, so it's just a you transform the English words to a picture. Okay, suppose that family living on campus, M is they will experience mechanical problems. T is they are going to have traffic violation, have a ticket, and V is they will arrive campus with no vaccines. Okay, so V, MTV, either one is not good. I don't like those. Okay, you don't want to have mechanical problems. You don't want to have a ticket. You want to have some space to stay. So now refer to a company Venn diagram. Now let's say the family will experience no mechanical problems. So M just explain one. M is mechanical problems. Okay, so no mechanical problem is the red area. Then it says what? Will not receive a ticket. Okay, so this is ticket. The second is ticket. So we don't have that. Okay. So ticket is, the second one is ticket. So no ticket either. And then, but will arrive campus will arrive at a campsite with no vaccines. So no position, no place. Now this is no place, vaccines. Okay. And then you have, it's just the part 6. Okay. I think it's pretty simple. You can just draw the picture and transform the words into the parts, the picture here. Okay. Number 6. So you have 8 ways of blood type. For each one you have 3 choices. So you have high, low, normal, and high. So basically you have AB plus, low, normal, and high. And you have AB minus, and you also have 3, low, N, and that. And you also have A plus, you have a low, normal, and high. Then you can see you have 1, 2, 3, and continue. And A minus, you have 3 options. And B plus, you have 3 options. B minus, you have 3 options. O plus and O minus. For each of them, you have 3 options. So together, it's going to be 8 multiplied by 3 is 24 different ways. Okay. Number 7. A study concludes that following simple health rules can extend to man's life. Okay, we can continue and skip that and read the problem yourself. And then it asks you if a person presently violated 6 of 7 rules. Okay, so he violated 7 of 6 rules. Right now, how many rules does he obey? 1. Okay, so 1 rule he obeys. Now, a person adopted 5 of those rules to follow. In how many ways? He has already obeyed 1 rule. So he needs to obey 4 other rules to satisfy adopt 5 rules. So now he has 1 rule. Okay. Presently, he violates 6. So which means he follow 1 rule. And he needs to adopt 4 other new rules. So we have how many rules in total? We have 7 rules in total, and he will have to adopt 4 new rules, and which is select 4 from 7. Is 7 factorial over 4 factorial times 7 divided by 4 factorial. I've already told you that if it's a select 4 from 7, basically you just need to do 7 times 6 times 5 times 4. 4 numbers from 7 from the top. And 4 numbers from the bottom, 4 times 3 times 2 times 1. And then you can reduce it. And then equals 35. Or you can use the formula to do 7 factorial divided by 4 factorial divided by 3 factorial. Or you can select 4 numbers on the top, 7 times 6 times 5 times 4 numbers. And then 4 numbers from the bottom from 4, 3, 2, 1 divided. Okay? That's this one. Oh, if a person gets between 7 and 8 hours of sleep, and the part B, it means that person has already have 1 rule, so it's been selected. So that one has been fixed. So now we only have 6 rules available, and he needs to choose 4 from the 6. Okay. Because a person gets between 7 and 8 hours of sleep, which means he has already, that rule is fixed. You only have 6 rules remaining to be selected, and you only have to choose. Since he adopt 5 rules, so he needs 4 more rules. So you have 4 from 6, and you have 4 times 6. Sorry, times 4 times 3 divided by 4 times 3 times 2 times 1, and cancel out. You have 3. You have 15. Okay. How many different ways can true-false test question consist 9 questions be answered? So each question have true or false. Okay, so each question have true or false. How many different ways? So for each one you have a true or false. You have 9 questions, so it's 2 to the power 9, which is that. Okay. It's because it's the continuous. The first one be true and false. And then you can do true or false, and then you can do a true or false, and then you can do true or false. So it's going to be 2 to the power 9. For each one you have 2 ways. So basically it's 2 times 2 times 2 times 2 times 2. You have 9 2's times together is 2 to the power 9. Okay. Lesson 2, a multiple choice of 6 questions. Sorry, my bad. It's question 9. And okay, this is very similar as the previous one. I'll skip this one. If you really need help, I'll do that. Okay. How many ways can the 4 boys, 3 girls sit in a row if boys and girls must alternate? So now there are 2 ways to think about it. If I have 4 boys, so it's 1, 2, 3, 4. Those 4 boys have already seated. So then you have 3 girls sit in between. And it's going to be 1, 2, 3 because they have to must alternate. you have to sit in this way. But they can sit, the boys can change the position, so it's 4 factorial. And the girls can also change the position with each other, but the positions change, but they can switch to 3 factorial. Okay? Or you can sit the girls first. Girls sit here, and then boys must sit each one, so you have that. Okay? That's the only way you can sit. Okay? Then you have the girls can change, so it's going to be 3 factorial and multiplied by 4 factorial. Okay? You may ask me, okay, so what if the boys sit like this? If the boys sit 1, 2, 3, 4, then the girls can sit 1, 2, 3. That's not okay because these 2 boys sit next to each other. Okay? So once the position is fixed, they must sit like this way. 1, 2, 3, 4, sit here, and 1, 2, 3. Okay? And then, but they can switch with each other, the position. So that's 4 factorial for the boys can change. For the girls can change, you have 3 girls, you have 3 factorial multiplied together. That's the answer. Okay? Alright, so let's look at this. Experiment involves of tossing a pair of dice. It's a pretty easy one as well. Okay. And then let's just look at the probability. The probability of A, even A is that the sum is less than 8. The sum is less than 8. It's 1, 1, less than 8. 1, 2, less than 8. Because you add those 2 together is 2. Add those 2 is 3. You add those 2 is 4. And 1, 4, 1, 5, 1, 6. Okay. So all of this add together is 7. And continue a second row, you have 2, 1. You have 2, 2. You have 2, 3. You have 2, 4. You have 2, 5. This add together is less than 6 as well. The third row is 3, 1, 3, 2, 3, 3, and only 3, 4. You continue your last one, you only have 1, 6, 1. So you add all of them together, it's going to be 6 plus 5 plus 4 plus 3 plus 2 plus 1. That's the total options of the sum less than 8. But how many combinations, how many ways do we have in total? Sample space, we have 36 in total. Okay, so then you have that is going to be cancelled as 20. You find out that 7, 7, 7. So it's 21 over 36, which is 7 out of 12. So basically, you just need to count how many ways satisfy the condition and divide by the total. Okay. Next one. Number 12. A box contains 500 envelopes. $25 contains, 25 contains $100 cash. 100 contains 25. 375 contains $10. Envelope must be purchased by $25. What's the sample space for different amounts of money? Assign that. Okay. So the sample space is $10. You have 375. I think I want to choose the black ones. Of 375 for the 10, the total weight is 375 divided by 500. That's the weight for $10. You have 75% chance get $10, and you have 100 divided by 500. So basically, you have 20% chance to get $25. And if you go like say 25 divided by 500, and then you can win. You have 5% chance to win the $100. Okay, so you can look at here. Most likely you're going to lose your money if you buy that. 70%, 75% chance you get $10. Okay, and you only have 5% chance to win $100, and the 20% chance that you're going to don't lose anything but don't win anything. That's it. Okay. So the probability that the envelope purchase less than 100 is, you got the envelope and the inside is less than 100 is 0.75 and 0.2. These two together, so you have 95% chance you don't win $100. Okay, you don't win anything. Okay, this one, the probability that an industry are located in A, so it's PA equals 0.5, and PB equals 0.7, and PA. Okay, that probability that I will look at either A or C. Okay, this one is P, either A or B or both is 0.8. So P union B equals 0.8. You will need to use these three and use the formula PA union B equals PA plus PB minus PA intersection B to find out that first one you find this, okay, that first one you find PA union PB, sorry, PA intersection PB. So basically you just use, you plug it into here, 0.8 equals 0.5 plus 0.7 minus PA intersection B, and you see that it's going to 0.4. Okay, and what's probably the industry in neither city. So basically is you're going to find out the complement set of A union B, which is 1 minus PA union B, and which is 1 minus 0.8, which is 0.2. Okay. A pair of dice is tossed. Find the probability that getting a total of 3 and almost a total of 4. You just do that by yourself. I think you can do it. You do yourself 1 1, 1 2, 1 3, 1 4, 1 5. Use that chart. 1 6. Use that chart. You have 6 1, last one 6 2, like that, and the last one is 6 6. You have 36 in total. And getting a total of 3, you only have 1 2 give you a 3, 2 1 give you a 3. So basically 2 out of 36. You do that by yourself. Count how many give you that, and divide by total 36. Okay. Next one. Suppose 2 books are picked at random from a shelf containing 4 novels, 6 books of poems, and 1 dictionary. Find the probability that a dictionary is selected. Okay, so you have choose 2 books. So the first book is a dictionary. How many dictionary do we have? We have 1. So choose 1 from 1. And then we have choose another book from the rest books. So we have 10 books, 4 novels, and 6 books poems. So 6 poem books. So we have 10 books. We select another one from these 10 books. And what's the probability of that happened? So basically choose 2 books from the total 11. So that's how you find the probability. And then you got the answer. Okay, you know how to do this 11 or choose 2 from 11. Choose 2 from 11 is, this one is 10, very easy. Choose 10. Choose 2 from 11 is 11 times 2 from the, sorry, 11 times 10, you know that 11 times 10, at the bottom choose 2 numbers, the bottom choose top choose 2 numbers for 11, bottom choose 2 numbers from 2. We cancel that out, it's 5, so it's 55, and it's 55 here. Okay, and you reduce that, you got 2 over 11. That's the first question. How about the second question? The second question, find a probability that a novel and a book of a poem is selected. So the first one, you choose a novel. So how many novels do we have? We have 4. So we choose 1 from 4. Second one, you choose a book of poem. How many poems we have? Poems we have 6. And we choose 1 from 6. And a total, you just choose 2 randomly from 11. And find that probability. Okay? You see my dear. What is the probability that the person is male given that the person has a secondary education? The person has a secondary education, we can look at together have a secondary education is 85 plus 85 secondary education. But it's a probability is a male, only 85 of them are male, so it's 1/2. Okay. Second one, what is probability that a person does not have a college degree given that a person is a female? How many females do we have? We have 111 plus 85 plus 60. That's a total number of females. You can see that the first column. The total number of females. But what's the probability that they don't have a college degree? They don't have college degree is 115 had elementary, 85 have secondary. But that's the number they don't have. This is the number that the female does not have a college degree, and that's the total number of females. And then this is the probability, which is 10 out of 13. Okay. The probability that a married man watches a certain television show is 0.5. So let's say a man watch a TV is 0.5, and the probability that a married woman, female or woman, I would just choose husband and wife, sure. Okay, because it's a couple in the video. So a married woman watch that is 0.6. A probability that a man watch the show, given that a wife does. That's why I said I need to use a W, but it doesn't matter, it's just simple. Given that a wife watched that, and the man watched TV, it's 0.7. Now, we want to find out the probability that a married couple watch the show. So that's the probability of both of them watch. So it's intersection of that. Okay. The formula is what? The formula is PMF. F is the divided, so denominator is the denominator. So PF and the P, M, and the F. Okay. So here P, M, and F. So both of them watch the TV. It's going to be you multiply both sides by probability of female the woman watcher. So P, M given F, and multiply P, F. Does it make sense? And then continue to here equals, given that female watch it, the wife watch it is 0.7, the husband watch it, and the wife watch it is 0.6, and then equals 0.42. That's for the first one. Okay. The second one, find the probability that the wife watch the show given that the husband does. So it's probability that wife watch the show given the husband does. It's like this. Given man watch and wife watch. Okay. And then you know the formula is both of them watch first and divided by the probability of man watch this. It's the division kind of. And you plug it in. So both of them watch it is 0.42, and the probability of man watch it is 0.5, and this give you 0.84. Find the probability that at least one member of a couple watch a show. So which means you're going to need to find out P, F, union M, either one of them or both. Okay, so at least one. It's going to P F plus PM and minus PF intersection M. Use the formula. PF is given 0.6. PM is given 0.5. And together they watch together. Both watch together is given 0.42. So answer is 0.68. Okay. A town has 4 fire engineers operating independently. The probability that a specific engine is available when needed is 0.8. So probability is available is 0.8. The probability that the engineer is not available is 0.2. Okay. So now what's the probability that no fire engine, sorry, it's not engineer, it's engines. No fire engine is available is, first one is not available is 0.2. Second one is still not available. Third one is still not available. Fourth one is still not available. So together is 0.0016. Okay. Now the probability that a fire engine is available when needed, so this is none of them is available. Now at least 1 is available, so it's 1 minus that. Okay, complement set. Okay, this one is the one we said is we use the Bayes rule. Suppose that a diagram of an electric system is shown what's the probability that a system works. Assume that the components fail independently. So now, so first, all of them working is going to be A intersection B or C. Either one of them is working. I think the whole thing is working, right? You can see that. And the intersection is D. Okay. So basically is probability A, because all of at least the A has to be working for sure. Either B or C has to work, and the D has to work. Otherwise, the whole system is not working. That's the engineering picture, pretty much. So you have P, probability of A is working multiplied by probability B or C multiplied by the probability of D. So A is given, which is simple. D is given 0.8. Well, we now need to find out PB union C. Then B or C, you need to use that formula. PB union C equals PB plus PC minus PB intersection C. So PB is 0.5, PC is 0.6, and B intersection C, since they are independent, so it's just PB times PC. So it's 0.5 times 0.6 because they are independent. Then this will give you 0.8 as well. Okay, this will give you 0.8. Then you plug into here, and the answer is 0.5888. Okay, so that's how you explain this problem. Last one. Okay, this is the Bayes rule as well. 35 a new business in 2013 in woman. So 35 is a woman, and which means 65% is the woman, so it's female, and then this is the male. I should say F, or woman is fine. And 20% of a new business. So out of 35%, 20% are 50,000 above. Okay, so or 22% new business started by men is that, so it's 0.022. It's 50%, 50,000 above. A new business started in 2013 and selected randomly, and they had a revenue. How did this? Okay, how did this one happen? And what is the probability that business was started by a woman? So the business started by a woman is 35%, and only 20% have 50% above. So it's 0.35 times 0.2. Okay, divided by that a business started and have 50% above. So it's 0.35 times 0.2 plus 0.65 times 0.22. Okay, and then this will give you the answer. This is a business started 20% out of the 35%. 20% out of 35%, and you have to add the men as well, because that's in the total. When you do the probability, you do 1 and divide by the total probability. So that's going. The answer is going to give you that. Okay. So that's the homework. If you need help, just let me know. But it's not really hard. Before you before you watch the video, I think you always have to try yourself and think about it really hard and see if you can do yourself. Okay. So that's it, and see you next time.